Yeah, ठीक. Okay, great. So now we will go a bit slow so that now first question. So I would ask few questions first, which will make your understanding better. You can see the question in green that says this is a constellation diagram for 8 PSK, right? So I make this statement by observing this constellation that all symbols have equal energy. True or false? How many of you says it's true and how many of you says it's false? Just count. All of you have to say something. आप लोगों को just hand raise करो for true. Count करो अभिषेक कितने? How many of you says true? I am not going to see it. I am not looking into it. मेरा तो वही खुला हुआ है. Just Abhishek will count. Whoever is saying what I don't know. So just say, tell it. Whatever is your understanding. Right. And as I am not watching, so there is, this is anonymous. So you can do it. For true. Only true पूछो अभी. Right, only right. This you will also say true. How many of you say false? So there are 4 votes for true out of 22. For true, the votes are increasing. Okay. How many of? Okay, false. How many for false? No one. 2, 3, and around 11 says no, nothing. So they are not saying anything. So next comes the justification. Once the voting is done, what is the justification? How false, the people who are saying false, what is the justification? Just ask the justification. Anyone who raised the hand? I am not watching, just open your mic and you can speak up. Okay, for true, anyone? Abhishek? Hmm. 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 No, don't you see the point of plotting this red? Okay. Yes. Very good. So this is the perfect justification that all are equidistant from the origin. Since it's a PSK, right? And I told you that PSK, the only the factor which differentiate between these points is the phase. The amplitude of everyone is same. That is why it is called phase shift K. You are shifting phases, right? As per your information. So since as Abhishek correctly uh, stated that all the symbols are equidistant from the origin, or as they lie on the circle they are equidistant. Circle which is centered at origin, the distance is same or equidistance from the origin, and therefore all are having equal energy. Very good. So, what is the average energy of this if all of them are equiprobable? The energy of any, right? Energy of any, you will say, gives you the average energy. Very good. Now, let us come to the next type of very useful constellation, and in I think 4G we use 256 com. Just check it. Check it in 4G or 5G. Just check what is the maximum or what is the modulation scheme, generally used modulation schemes for 4G and 5G. Have you checked, Abhishek? Just check it. See, it's like a break. The question is what fourth generation and 4G and 5G, right? All of you are aware of that, right? In wireless communication, you are shifting towards 5G, right? So, what is the, तो वहाँ पर भी तो that, so this all we study, right, for some purpose, right? So, what is the constellation or bit 2 waveform mapper used in your mobile phone or in your base station which is using 4G? Your phone is 4G, right, or 5G? 5G. ठीक है, 4G पे देखो, मोस्टली तो हम 4G पे ही रहते हैं. It's volte, right? LTE. In LTE, which constellation is used for the signal transmission, or what type of bit 2 waveform mapper is used?
So, I got this answer, sir.
What?
Waveform mapper 4G.
No, no, bit 2 नहीं, वो तो मॉड्यूलेशन हो. कॉन्स्टलेशन देखो तुम.
Constellation mapper means takes groups of bits and
हाँ, करेक्ट. अच्छा, मॉड्यूलेशन स्कीम देखो, राइट. टाइप द टर्म मॉड्यूलेशन. विच मॉड्यूलेशन स्कीम इज यूज्ड? Everyone please see it. So, it's like a break, right? Rather than giving you a break, I am giving you these exercises.
in LTE advanced
Okay.
256 QAM,
Okay.
8 bits, very high data rate.
Okay. Okay. So, what do you mean by that? So, क्या स्टेटमेंट है? 8 bit 256. These are the keywords, right, which you have just told. I am just writing the keywords. 8 bit 256 QAM, high data rate. So, he searched for the modulation schemes used in 4G or 5G?
4G.
4G.
LTE.
LT. LT stands for long term evolution. Anyways, so that is not that important to us, but these are the keywords which Abhishek has come up. So, have we studied QAM yet? I have given you a just touched upon this topic, right? QAM. What was QAM? Okay. Eight bit. What do you mean by 8-bit? It means your bit to constellation mapper or bit to waveform mapper, it takes 8 bit at a time. How many possible combinations? 2 to the power 8, which is equal to 256. So now you can relate कहाँ से आया ये, how you have got this. Now what is this QAM? So QAM is a particular type of mapping which takes into account please all of you, yes Ranjana, you have raised your hand, is there any, okay, anyways, yes. So quadrature is a more generalized modulation scheme or bit to waveform mapper, where in PSK we only change the phase and in ASK we only change the amplitude, but in QAM, if you remember, I just touched upon this topic, we change both the amplitude and Abhishek, batao. Yes, we change phase and amplitude. So again, नहीं कुछ मैं बता रहा हूँ आपको. So here we have seen that the information was embedded only in the phase part, right? Yes or no? But here the information is both in amplitude and phase. As you can see, between these two constellations, the phase is different, yes. The amplitude is different, yes. In all of this, you can see that amplitude is same, only phase is different, right? And if you remember, I will just write ASK. What is ASK? Amplitude shift keying, and we embedded the information here. So any amplitude ASK signal, how will you write ASK signal? नहीं, इस पार्ट को स्केल करें. So this is your phi t, only one phase will be there. ASG is a one dimensional constellation. As you can see, it's a one dimensional constellation. There is no second basis, and all the points will have phase 0 and all the points only differ in amplitude. If this is origin, if you remember, I told you, you can do something like that, right? Some alpha. Only amplitude, right? Not cos, the amplitude of cos. So you are scaling. Alpha is some, again, the factor. So this is a 1, 2, 3, 4, 5, 6. 6 is not right. 1, 2, 3, 4, 5, 6. 7, 8. So you are taking 3 bits and you can map it like this, yes or no? Now you can write what is the value of AI. A1 is k alpha by k, oh no sorry, alpha is 1 by k, this is accordingly you can write, right? If there is some doubt, I can further elaborate it? This is clear, right? I am just making this constant to normalize this. I am just making this alpha so that you can spread it. You understood my point? Why I am using these two constants, where alpha and 2, they are normalizing factors, scaling factors, to keep some flexibility, right? If you increase alpha, what would happen? Sorry, if you increase, yeah, they will spread up, right? If you, and this k is just to normalize it. So these two are different. Understood my point? So, or in general you can write, there are various ways, so you can write. So, if somebody says this is my ASK waveform, then you have to write okay, then AI by k cos 2 pi FCT. So, you can write okay, I can represent my each point of the ASK कैसे AI by k है ना. AI की वैल्यू कहाँ से होगी? There are various ways to represent things. So, let us take one. ASK क्या है? Cos 2 pi FCT, phase is fixed, you are changing only the amplitude. Yes, you are changing the amplitude. Now, your aim is to write each of these in terms of basis. So, there is only one basis cos, just you need to normalize it. So, I have used a factor k, so that this becomes unit norm. You understood my point?
Yes, sir. But how does we need to normalize it?
Because of the very definition of the orthonormal basis, that all the bases must have unit energy, and the constellation points are always plotted with respect to basis. It makes analysis easy. For example, when this happens, then you can say that energy of each point, each waveform is the distance square. If you remember, when I used to prove this, that what is the energy of a waveform which is distance square, I used these two. Yes or no? So, these properties we use, and in general also when we talk about basis, there are always unit energy. ठीक है? Unit norm or unit energy. So, just we make this unit norm. So, k से multiply कर दिया. So, now accordingly you have to adjust your aim is to draw, right? You understood my point or not? So, that is not a big deal, that is why I am not giving much attention to it, it is very easy. So, your SI is AIK, because there is only one basis. So, k is a constant and AI will take value according to whatever you set it, right. So, AI you can set 1, 3, 5, 7, minus 1, accordingly you can set. And further देखो अभिषेक होता क्या है, in general in every setup whatever constellation point, this is bit to constellation mapper, yes or no? यहाँ पर क्या करना है आपको, वेव फॉर्म्स निकलेगा, यस और नो? There are m possibilities, yes or no, depending upon the number of bits. Yes. So, now comes the point of analysis. So, in terms of analysis, what we said, or one is analysis and one is implementation. That is why we converted it to basis, right? Remember? So, I told all the PSK except m not equal to 2 have 2D, white phi 1t and phi 2t. All the PSK waveform you can write like this. This we have seen. Yes or no? बोलो भाई.
So why? Okay. Why m is not equal to 2?
If m is equal to 2, then it becomes one dimensional. When m is equal to 2, there are only 2 points, so there is no concept of fight. So when you try to find out the basis, it will come only one. So it's a 2-dimensional constellation for m greater than 2. For m is equal to 2, it's a 1-dimensional constellation. So once we have this constellation or this phi 1t, phi 2t, क्या करते थे हम लोग? The factors, right? How your S1 is S11 and S21. Similarly, S1m to S2m. Yes or no? फिर आप इससे ऐसे ही तो करते थे ना. सेकेंड पॉइंट, these are the projection point, but in order to generate S1t, what you have to do? S11 phi 1t, S21 phi 2t, and you will sum it, right? So for PSK in general, we have a 2D constellation. If m is equal to 2, then second points become 0. So यहाँ पे 0 रहेगा. You understood my point? So this is a PSK. ASK में क्या होता है? ASK में this point is always 0, only this point changes, this value changes. Understood my point? हाँ. So अभी QAM क्या है अभी? Now the QAM is combination of ASK and PSK. बस वही समझाना था. Yes, amplitude, but how would you know that? You need to first draw the all the QAM waveforms. If you draw its constellation diagram, you will see they will not lie, they will, okay, ASK, all points lie in a line. Yes or no?
Yes, sir. One dimension.
Yes. PSK, all points lie in a circle except m is equal to 2, which you can call it ASK. So just remove it. So that is why when I write PSK, I say m greater than 2. ठीक है ना?
Yes, sir.
अब बताओ QAM, all the points will neither lie in a circle nor lie in a something like this.
They can lie anywhere, anyhow, right?
क्या बोल रहे हो?
Actually, they can lie anywhere, anyhow, right?
Anywhere anyhow nahi, that you have to design accordingly, but few of them. So this is a example of 8 QAM. I have drawn my 8 QAM in such a way that these 4 points lie in one circle and another 4 points lie in another circle. Or you can do like this. So yes, so we are now combining. Degree of freedom will be more, right? If you have a constellation point where you can make them different amplitude and different phase, you can have more freedom. So these are my 8 constellation point which I wish to put like this. अभी क्लियर है? So I hope, So, you can easily say that this is a
Yes, sir.
COM, and all the COM constellation are 2D constellations with phi 1 t as this form and phi 2 has this form, where k is a normalization factor and all points satisfy this. They are sum of phi 1 t, sum and phi 2 t, but so as you can see, this will have same phase but different amplitude, this have same phase but different amplitude, this have same amplitude but different phase. So, this is how you can differentiate. So, QAM is a more general form of modulation scheme or constellation designing, which is a combination of ASK and PSK. Now, have you understood? Okay. Now, this is R1, this is R2. What is the average energy of this scheme? Given this is pi by 4, this is 2 pi by 4, 3 pi by 4 and 4 pi by 4. क्या करोगे? Energy is distance of all points from the origin, उसका square. So, what is the energy? R1 square plus R2 square plus R3 square plus R4 square. Sorry, in my. So, all of these have R1 square. So, 4 R1 square plus 4 R2 square, and each are equiprobable. So, this will be the energy, average energy. Yes or no? Average energy of nikal, very easy, right? ठीक है, so don't make these mistakes if I ask questions in the exam. So, average energy of a constellation, QAM constellation, you can find like this. So, now your point is
R1 is the R1 to
I am just saying it is R1, R1 can be any value, right? So, but फिर अगर R1 okay, so S1 t you can write in terms of, anyways, don't. So, I have just given you, if this is the value R1, this is the value R1, R2, you can evaluate average energy. Now, the question is write equation of all the waveforms. कैसे लिखोगे? First, you have to make sure that I would ask if it is a QAM, you will answer yes. Second question, what is the average energy of this constellation? You will answer R1 square plus R2 square divided by 2. Now, I will write the equation of all. So, how would you write? If this is S1, this is S2, this is S3, this is S4, this is S5, this is S6, this is S7, this is S8. Very good. So, S1t will be R1 phi 1t, sorry, R1 into cos pi by 4. The projection, you have to find out this for this, in this constellation, what is the amount of phi 1t? R1 pi by 4, R1 cos pi by 4, sorry, yes or no? So, you have to write R1 cos pi by 4
plus R2 R1
sin
sin pi
by 4 phi 2. So, this is your S1T. Similarly, you can write for all, है ना. So, आपका कौन सा क्वेश्चन, यू हैव नाउ 8 बिट क्लियर हो गया. 256. So, if you have a 256, this is the example of, this was the example of 8 QAM. So, for 256, how many points will be here? Bolo, how many constellation point will be there? 256.
सर वो ऐसे ही अरेंज किया जाता है और ऐसे भी
कॉम और पीएसके को, एएसके और पीएसके को मिक्स करके. आपको क्या चीज़ें कंट्रोल करनी है? पावर और डिस्टेंस. पावर क्या बताता है? व्हाट इज, और एनर्जी, एवरेज एनर्जी. यू हैव टू कंट्रोल एवरेज एनर्जी एंड यू हैव टू कंट्रोल द energy will decide how energy efficient is your system, and D will decide that the minimum distance will decide how reliable is your system or how well it performs over noise. Correct? Yes or no? So, what taking into account of these two factors we design the constellation. अभी समझे कि नहीं अभिषेक? हाँ. So, please count 1, 2, 3, 4. How many points are there? It is 64 QAM. 256 is further you have to. So, let us discuss 64 QAM. So, in 64 QAM what would happen? Each bit has, each symbol will represent how many bits? बोलो. $64 bit, right? Sorry, 6 bit. So, each constellation point something like that. इसका क्या मतलब हुआ? 64 QAM takes 6 bit at a time. So, how many possible combinations? 64. So, it maps each of these point to any of this, I mean respectively you map the bit combination to each of these points. You understood? So, if I transmit one symbol at a time, how many bit of information I can transmit? If there is a perfect channel, you can identify, if you transmit this for example, and at the receiver it contains 6 bits, right? Yes or no? Is this clear or not? That what do we mean by 64 QAM? Each constellation you are mapping, you are taking 6 bit at a time, you are mapping it to S1T. So, each of this waveform which is represented by this constellation point carries 6 bit of information. So, at the receiver you can, if you transmit S1T, you can extract 6 bit of information. Yes or no?
yes sir.
Huh. So, if I move to 256 QAM, which is 2 to the power 8, I have to arrange these points like this. So, accordingly I have to put the points in this constellation, but now each waveform will carry how much information? 8 bit, yes or no?
Yes, correct.
So, what was the last sentence or last keyword which you used? High data rate. So, if you use 256 QAM, what you can do? You can transmit 8 bit. Yes or no? Bolo bhai.
Yes, sir.
If you use BPSK, you can transmit only 1 bit. If you use 64, you can transmit 6 bit. So, this was the 3 keywords which you used. Now, you have understood?
Yes.
Okay. So, QAM is a dash dash dimensional constellation. What is the answer? 1D, 2D, 3D, none of the above. What is the answer of this? 2D, very good. Why? Because we had only two bases, k cos 2 pi f c t, k sin 2 pi f c t. ASK is a 1D constellation or 2D constellation or 3D constellation? What is the answer? Yes. And all points lie in a line. In a second, 1D line, 2D line, 1D circle. So, what would be the answer? A. ASK is a one dimensional constellation and all points lie in a circle. Sorry, in a line. PSK is a constellation and all points lie in a, बताओ please quickly. Phase shift king is a, हाँ, m is greater than 2, is a 2D constellation and all points lie in a circle. Very good. अभी क्लियर हुआ सब कुछ कि नहीं? QAM is a constellation and all points lie in dash. QAM is a, what would be the answer? And all points lie in a 2D plane. अभी सब कुछ क्लियर हो गया, सारी हिस्ट्री? Yes or no?
Yes.
So, QAM is a very generalized which contains both ASK and PSK in it. Yes or no?
Yes.
So, we have started with a very general block diagram or general bit to constellation mapper, where we said we can have any waveform and we can have any point in any space, any basis. Then we discussed most popular schemes, modulation schemes, PSK, ASK, PSK and QAM, and we have seen that for them the bases are 2 and for ASK basis is 1. So, if these are the popular schemes which you use for digital communication or wireless systems, a very simple transmitter design can be obtained now. You have to just bit to waveform mapper now has become wing to constellation mapper, yes or no?
Yes, sir.
For example, 0 0 will be mapped to S1 vector which will have two components S11 and S21. 0 1 will be mapped to S2 waveform which is S12, S22 and so on, and the first will go here and the second will go here. You will sum it and you will transmit it. Any general PSK waveform can be written like this. ठीक है ना? So, how would you design the receiver? बोलो. क्वाम होगा तो क्या होगा यहाँ पर? The things will change, right? Only this equation will change or this mapper will change and everything else. This will be constant for अच्छा बताओ ASK में क्या होगा? Is this will change this part which we also call up conversion. This is called bit to constellation mapper. So, in ASK what would you do? You will use some this mapping and these values will go here and here always 0 will be there. Yes or no?
Yes.
So, this will not change, this will be fixed. This is called up conversion block. This up convert your frequencies, bit to constellation mapper. Here you have to design a mapping scheme that if for example 1 2 3 4, let us take example of 4 ASK, 0 0 will be sent through 0 1 1 0 and 1 1. So, 0 0 will be sent through cos 2 pi f c t minus cos 2 pi f c plus cos 2 pi f c t. 0 1 can be sent by 3 cos 2 pi f c t. 1 0 will be sent through. Okay, let us do this example. It's a good example. 0 0 we are transmitting through cos 2 pi f c t. This is the last example and then we will end. Draw its constellation diagram quickly. This is a 4 ASK scheme. Draw its constellation diagram and then design bit to constellation mapper. तो क्या होगा बोलो, 0 0 विल बी, I just put a constant k which will normalize this, I call it phi 1 t, k is required so that we want its energy to be 1. So, 0 0 is mapped to 1 by k, zero 1 will be mapped to 3 by k, in many of books what will you find, they will just write k cos 2 pi f c t and they will make everything 1, but ideally if you say that this is your basis, it must have the energy 1. So, a k is required and the value of k you need to do it in assignment. I will do it in the next lecture and tell you. Is this clear or not? Please ask if you have any. Sorry. So, this is the constellation. So, अभी यहाँ पर क्या करोगे आप, whenever 0 0 will enter here, you will just transmit, you will 1 by k, 0 1 1 0 and 1 1, accordingly you will do 1 0 minus 3 by k, 1 1 here always 0 and whatever is here you will just provide this. So, this will become your ASK. This will not change, only this part you have to modify according to ASK, PSK or COM. अभी ठीक है? Are you following whatever we are discussing till now?
Yes, sir. I'm following.
Okay. So, now if you have any doubt, please ask. Assignment is clear, just to draw QPSK waveforms and draw the QPSK constellation. And draw QPSK waveform. It will look like this. What you can do, you know the random bit generators? Have you used in Python the random bits? No? Okay, anyways. ठीक. So, I will not go much in this modulation now, and we have to see some. So, these are the most basic modulation, or not basic, I would say they are the most used modulations schemes, PSK, COM. So, nowadays as Abhishek told you, that we are using 64 to 56 COM, and the reason is apparent that we can transmit more number of bits, therefore high data rate can be achieved. Abhishek, do you have any query?
I'm good, sir. Just one thing,
Hmm.
all students were,
Hmm.
I mean, wanted to actually understand
Hmm.
exactly where their marks got put. So by any chance, it would be possible for you to discuss it now?
अभी तो फिर नहीं हो पाएगा, फिर नेक्स्ट टाइम में करेंगे, है ना? अगर ऐसा है तो वन बाय वन.
Actually, because lecture में I understand कि whatever the portion is very important,
Hmm.
but in such a session where we can discuss the paper.
हाँ, that's what I am saying, that in the next class, initial half hour, we will discuss that.
चलेगा, चलेगा.
I will show.
Sir, one more thing.
Hmm.
Now our final exam is 4 weeks down the line, right?
4 weeks,
So,
okay.
yeah. So syllabus में by any chance will you be able to give us an insight in how much is remaining and what all things weightage and
No,
individual concerns.
no, entire syllabus will be there, and
Where are we right now? I mean,
we are.
very
You can't relate. We are.
just some other thing.
No, only coding theory part may be remaining, which is second block, channel control code, channel codes. So I will just discuss few repetition codes.
So अपना first module हो गया ना सर, continuous and time discrete पूरा हो गया and continuous time Fourier transform भी हो गया. Sampling you taught us
Hmm.
CM.
Hmm. Hmm. Hmm.
And then module 4 is
Hmm.
AM, FM, TM. Are we currently on module 4?
No, we have covered AM. I have taught you, and I have given FM and PM as self-reading exercise. Because
Module 4 syllabus which I have
Hmm.
has PSK, QAM and everything.
So that is what we are reading.
Yeah, so we are on module 4, right?
We are almost done. Yes, a receiver, a bit I have to tell how to. I mean, you know how to design receiver, but just the bit. Hmm.
Previous syllabus का topic जो है ना,
Hmm.
वो एक subject में हमारा ऐसा हुआ था कि
Hmm.
सर दूसरा syllabus refer कर रहे हैं, हम लोग का दूसरा है. So
No, I am not referring any syllabus. I am just seeing whatever is there in your syllabus, as well as what is the most significant, which you must know in terms of communication. So that is what we are discussing. So we have start.
an exam paper will be based on whatever you are teaching in the class itself, right?
Yeah, 90% and 10% whatever I have given you assignment and self-reading, etc.
I mean, whatever that comes from you, whichever you have taught or given assignment, those
See, rest assured that whatever is taught here will cover all of the syllabus, most of the syllabus. Once you know that, if you go and read a book in future, you will be able to easily correlate whatever you have done. So if you now see QPSK, QAM, PSK, you can easily correlate how they are plot.
yes, it's module 4 I can correlate right now. I think we are on module 4.
Yes.
Then there is one module 5 channel coding error control.
Yeah.
I think that is pending, right?
The basic idea I have given you. If you remember, we have discussed repetition codes. We have started with repetition codes and how they can somehow improve the error performance. So once we are to the because if you want to learn that, you should know how receiver works. So once the transmitter part is done, so we will now move towards receiver, and then we will move towards how you can further improve the reliability by using.
That error thing is done, then we will be done for the portion.
One source coding theorem is given, so that I will tell you. Huffman coding, if that is very important in terms of for the sake of completeness, that is a source coding, first block. Second block is channel coding, so we will move towards channel coding and then source coding. I am going reverse. Generally people go from 1 to 3, I am going 3 to 1. Anyway, so I hope the things are clear now. And if there is no further query, we can. Yes.
This side, Ranjana,
Hmm.
will we receive any previous exam paper or the solved paper?
This is the first batch.
Then
You are having the first batch from our site. So since this is first batch from our site, you might be the one who will give papers to your juniors. So bad luck in that sense. Anyways, any other query? Okay, so thank you, and please do your